Alrighty? Alright, so look, one of the biggest issues on this test is the graphs. That's the biggest thing that's going to be wrong with this. Look at this graph. What is that graph counting by? Ones. It's counting by ones, but it's only listing every other point. So if you count it, it goes 1, 2, 3, 4, 5. The only struggle with this problem is identifying the x-axis. Which one is the x-axis?
The horizontal line.
Okay, that doesn't mean anything because I don't even know what horizontal means.
The one that goes.
The one that goes left and right is a great way to
What if I don't know my left and right though?
Then
Go back. Because I know like right and left, but.
so I'm going to go ahead and highlight the x-axis. Now you should be very clear which shape has a reflection over the x-axis. Don't tell me, because I don't want everybody getting free answers. So you can finish that problem by yourself, and that's how you're going to earn that 10 extra points on your test.
Yeah.
Cool? All right, so the second question was back on 8.6. What type of transformation is equivalent to two reflections across intersecting lines? Now, if you can't figure that out, you can draw intersecting lines.
Yeah.
And you can draw a shape that is easily identified as reflected. I like to draw this one. I draw an arrow like that. So you know where the top of the arrow is, you know where the bottom of the arrow is, you know which direction the arrow is pointing. We have to reflect that up over intersecting lines. It doesn't matter which direction you do it. You want to flip it left and right or up and down. Okay, so we're going to do this reflection first, which means it'll look like that.
Shouldn't she go like left?
And because I flipped over line 1 first, I have to flip over line 2 next. Does it make sense? So now it's going to flip that way. The only thing I'm interested in is what is the relationship between the resulting figure? Is it a glide reflection? No. Is it a reflection?
No.
Is it a rotation?
Yeah.
Yeah, so when you reflect something over intersecting lines, it is a rotation. Sorry, I did too much work there. Remember, if you don't have a review, where can you find it? In the Thursday folder over there. All right, number 3. Be very careful. What does this graph count by? 2's. It goes 2, 4, 6, 8, 10. And so does your test. So you have to put like imaginary lines in there for where 1, 3, 5, and 7 are. Now, it says that we're doing a composition of transformations. What is the first transformation you're supposed to do when you do a composition of transformations? You do the translation first, then you do, what do you do second? The reflection. All right? So, which direction does that translation move? Left, how many? No, that's not right.
0.
Oh, left 0? Yeah, that's what I was telling you. They're in the Thursday folder by the board. Left 0, and then which way does it go, up or down? It goes down 7. So I need to look for a shape that has been moved down 7. Are there any answers that are obviously wrong? I mean, like, have all the white triangles been moved down?
Yeah.
So that's not really going to help us. But now I might have to count a little bit here. If it went down 7, 1, 2, 3, 4, 5, 6. You see how hard that is to count? I'm going to have to go halfies. So it's 1, 2, 3, 4, 5, 6. That would move down 6. Is that right? No. One,
Oh, that's so
2,
easy.
3, 4, 5, 6. Is B correct? No. Okay, now it starts in the middle and it ends up on a line. It should be an odd number. 1, 2, 3, 4, 5, 6, 7.
Yes.
Possibility. Maybe. 1, 2, 3, 4, 5, 6, 7. Possibility. Maybe.
Yes.
So it's either C or D. And now I have to reflect it across the line x equals 1. So what does x equals 1 look like? It's a vertical line, and it goes through the number 1. So that should be right here is where 1 is. Or right here is where 1 is. Is it, you see the answer? No? Yes? Which one do you think it is? Are they even different?
D.
D? Correct. Because notice I go 1 to get to the pink line, and this one's 1, 2. Over here it's 1 to the pink line, this one's 1 to the pink line. So they have that x equals 1 symmetry. It's just hard because they don't show you that the shape slid down first and then it flipped over the line. That graph counting by twos makes it infinitely more complicated, doesn't it? And that's how your test is going to look. All the graphs are going to count by twos. So you can take some time and you can draw little lines in there. Alright? Number 4. Which letter has at least one line of symmetry? The dub, right? Is it, I mean, kind of, but not really. So see how that's kind of a weird answer? Like if you cut that W in half right here, does it look like it's been reflected?
Yes.
Yeah. So I changed it on the test, I made it an O. Because an O like is pretty obvious that a circle has a line of symmetry down the middle. Now,
W.
this one is, which one has rotational symmetry?
S.
S is the only one. So it said L.
Yeah.
Like the L, if you flip the L upside down, it look like this. Is that the same as an L right side up?
No.
No, it's not gonna work.
I knew someone was gonna say
So
that.
rotational symmetry is when you rotate like
Okay, so rotational symmetry. I'm trying to help you. Okay, so rotational symmetry states that if you rotate the shape, you should get the exact same shape. So if I rotate this shape 90 degrees, isn't it the exact same shape? Okay? So close your eyes. Close them. No peeking. Close your eyes. I'm going to rotate this shape. Do you see the exact same shape? Yes. It has rotational symmetry. Right? Now, does this shape have rotational symmetry? No, because as soon as I rotate it, I should see, no matter what happens after the rotation, an arrow pointing to the right. Is that an arrow pointing to the right? No, so that shape does not have rotational symmetry. Alright, this one is, so on the test it's going to have 4 different graphs. Which graph shows t -3 comma positive 3? Like what are you looking for there? Like, what has to happen for that rule to be true? What does -3, +3 mean?
Left 3, up 3.
Left 3, up 3.
Easy though.
So I have to take this shape and I have to move it left 3. 1, 2, 3, up 3. 1, 2, 3. So you're looking for a figure that's been moved to the left 3 and up 3. I know you guys want to accidentally do this. 1, 2, 3. Right? You want to do that, but you can't. And then 1, 2, 3. But is the pink shape at least moved in the right direction? Because you'll see answers that might look like this. Could that be correct? No, right 3 and out. Could this be correct? Could that be correct? The only answer that makes sense is a shape that's been moved 3 to the left and 3 up. Alright? Now, oh man, this one gets everybody every time. It even got me when I made the answer key. It was because I don't know how to read. I thought I was too smart for this. It says, you have vertices of a rectangle R, S, T, and U. A translation maps R to the point -4, 2. Find the translation rule for the image of rule. Find the translation rule and the image of U. So, it says, you have a rectangle and a translation maps R to the point -4, 2. So R was at -5, 5. Now R prime is now been moved to the location -4, 2. So how did I get from R to R prime? Right 1. So if I add these two together, or I subtract those two, you should get the +1. That's moving from -5 to -4. That's one direction in the right. And I went from -5 to +2. What's the difference between those two numbers? 2 minus -5. 7. So the translation rule is I went 1 to the right and 7 up. Just me? Now, is that the answer? No. What is the answer? The answer is
-1,
where
7.
did U go? So I have to take the point U and I have to move it 1 to the right, so -5 plus 1 is -4, and I have to move it 7 up. So 1 plus 7 is 8. So you have to find the rule. How did I get from R to R? Then you have to apply the rule to the new coordinate. It's a pretty complex problem. Lots of small steps there. Definitely recommend using graph paper for that one. You can plot those 2 points. And my graph paper back there is counts by ones. So I'm going to run off a bunch of those copies so you can have scratch graph paper for tomorrow. Hopefully this is a free question. Describe the words. Describe in words the translation of x represented by the translation rule t -2, 8. Left 2, up 8. And that's exactly what the answer is going to look like on your test. It'll all be multiple choice. Wait till she leaves and give it a free. Alright, number 9 is A.
A.
On your test, number 9 is A. Write A down on your test. Cool? Good. But for number 9 on the review, we're going to do a little work here. That was my key. Remember, number 9 is A on your test. When you get your scan card tomorrow, number 9, just bubble in A. Alright, because there is no correct answer on the test, so I have to fix that for you guys. This one says, which one maps the rule from here to here? How do I get from the green kite to the dotted kite? Left. 1, 2, 3. That's weird. Left 3. Up 2. So the translation rule would be -3, +2. That moves it left 3 and up 2. But what's the answer on the test? A. Again, I really recommend using scratch graph paper here. I'm going to kind of sketch it for you. On the test, it's only going to give you one coordinate. So let's say, what is P prime? So let's just look at P. P is at -2, -4. It says if you reflect P across the line x equals 0, what is P's new coordinate? Where is P prime? So how do I get from here, and which one is the line x equals 0? Does x equals 0 go like this or like this? X equals 0 goes up and down. X equals 0 is the y-axis. Remember, because x equals 2 is an up and down line. So x equals 0 is this line right here, the y-axis. So to reflect, I have to go 1, 2, repeat, 1, 2. That means my new coordinate would be +2, -4. There will be graph paper for you on your test. The big thing there is, do you know what the line x equals 0 looks like? Cool? Not cool? Is there a better way to explain that? No? Again, it would be so nice to have graph paper here. We're taking the point -2, -1. There's P. It says after 2 reflections, reflect that over y equals -5. So -1, -2, -3, -4. Y equals -5 is right there. So I have to go from -2, -1, down 1, 2, 3, 4. 1, 2, 3, 4. So I have to go down 8 units. So it's 4 units from here to here, and it's another 4 units down to the bottom. So -2, -1 becomes -2, -9. That's after the first reflection. Then I have to reflect it across the line x equals 1. X equals 1 is over here, like this. So I take a point that's at -2, -9, and I move it 1, 2, 3. I move it 3 units over. 1, 2, 3, and repeat. 1, 2, 3. So I have to move it 6 units to the right I gotta take this point and move it right 6 units, which would be 4, -9. This is why I always taught you guys to do it on graph paper, because it makes no sense when you sketch it out by yourself. Use the graph paper, use the graph paper, use the graph paper. Alright, the dashed line figure is a dilation of the solid line figure. So which one's the new figure? The dashed is the new one. The solid line figure is the old one. This looks very similar to the homework. Our scale factor should be new over old. So you need to count how long is the new figure. Which one are you counting? The dashed line figure is a dilation. So count the dashed one first. 1, 2, 3, 4, 5, 6. No?
Oh, hold up. Yeah.
1,
Yep.
2, 3, 4, 5, 6.
Yes. 6.
And how long is this one?
6.
How long is the solid line figure?
Oh, it is 2.
2. What is 6 divided by 2?
3.
Scale factor is 3.
That's it?
Yeah, I mean, that's what we did on the homework the whole time. So, does the number make sense? Is 3 bigger than 1?
Yeah.
So when the scale factor is bigger than 1, it causes an enlargement. Same thing here. The dashed line figure is a dilation of the solid line figure. So this is the new shape, this is the old shape. So we're looking for dashed over solid again. It doesn't matter how you count this. You might be able to cheat, make a mistake, and still get lucky. How long is this line?
8. Oh, 4.
4. Now, if you made a mistake and said 2, what if you did this? 1, 2. Let's see what happens. 1, 2, 3, 4. What's 2 over 4? 1/2. Now, if you counted it for real, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. Do you still get the same scale factor? Yes.
Isn't it new over old though? Or is the dash? Oh, the dash line is okay.
Your scale factor should be a number less than 1 because my dashed triangle got smaller.
Yeah.
I'll let you guys do this one. How many sides does that have? How many lines of symmetry does that have? How many sides does it have? Do you see the relationship there? If it has 8 sides, how many lines of symmetry does it have? Good? So if it's got 5 sides, how many lines does it have? 5. We did this, right? Remember doing this? We cut these things out and we sorted them. What kind of symmetry does a parallelogram have? Rotational? So if I flip this upside down, you should see the exact same parallelogram, right? Let's try it.
Yes.
Do you see that parallelogram on your paper?
Yes.
So it has rotational symmetry. Does it have reflectional symmetry?
No.
So the only answer here is sorry, my bad. I can't read. It's over here. My bad. Okay. It took me 20 minutes to do this problem last time I did it.
Oh.
You know why? Because I can't read. So, look at what this is saying. And this is like, how much geometry speak do you know? If you do a reflection composed of a translation to triangle RST and get triangle R double prime S double prime T double prime, what are the coordinates of R, S, and T? Look at that. What is that?
I don't know.
That's R double prime. That's after both translations. It wants to know, what are the OG figures? Where did this come from? So you have to go backwards to figure it out.
Okay.
Now, when you do a composition of transformations, which one do you do first? T. This is the first step when you're doing it, and this is the second step when you're doing it. But when you're undoing it, you have to do the second one first. You see how this can get uber confusing. So I have to, step number 2, go backwards, reflect it across the y-axis. 1, 1, 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4. This is R prime, T prime, and S prime. Now I have to undo a downward slide, which means I have to slide it
Upward.
up. Now I'm undoing a downward slide that went down 4. So I have to put it up 4 units. So I undid the reflection. Now I have to undo the downward slide. Move it up, 1, 2, 3, 4. Move it up, 1, 2, 3, 4. Move it up, 1, 2, 3, 4. So when this problem started, that's where R, S, and T were. So if I slide this down 4 units, then reflect it, that's why this shape is here. On your test, it's only asking you for the location of 1 point. You don't have to do the whole figure. Undo a reflection for 1 point and undo a slide for 1 point. Can you do a slide that's 2, 2? It says T2, comma 2. Can you do that slide?
Yeah.
So what does that T2, 2 mean?
Right to.
Right 2, up 2. Ready? 2, 2. Did you fall for the trick again? Because look how this graph is counting. 1, 2, 3, 4, 5, 6, 7, 8. Graph's counting by 2s. So it's over 2, up 2. Over 2, up 2.
You can't be
Over
switching the
to-
graphs like that on this.
Dude, I tried.
Yeah.
Like, I literally reformatted so much of this test. What I couldn't do was redraw every graph. That's my goal for next year. So I want to make it super obvious that these graphs suck.
Next year?
I mean, I can only do so much at a time. I just don't have time.
Oh, okay.
Okay? Can you reflect something across the x-axis? Okay, which one's the x-axis?
Horizontal line, so left to right.
This guy right here. So you gotta reflect that figure across the x-axis. And last one. Ooh. We learned this yesterday, right? Or 2 days ago. Can you do a dilation with a scale factor of 2? How do you do dilations? What? Multiply. So you just take the coordinate locations. This is at 4, 2. Because it's 2, 4, 2. A graph counts by 2s. So you have to multiply each of those coordinates by 2, which will become a 4. So over 8 up 4, that's where B is. Do this one down here, it's at -4, -4. Multiply each of those points by 2, because the scale factor is 2, which becomes -8, -8. Find these points, that's at the location -2, +4. Apply the scale factor, which is 2, -4, +8. So it gives you a brown triangle that's 2 times density.